Welcome to my talk. Thank you very much for coming. I'm very aware that I'm the last speaker between this conference and the pub, or just resting after taking in so much information today. I'm here to talk to you about observability. And basically what I'm going to do is I'm going to give you some practical advice, some tips, which are supposed to be fairly simple in terms of being able to easily implement them and fairly practical. And I think that you will either learn something new today or at least your existing kind of like ideas will be challenged. And I really hope that the talk will be useful for you. So my name is Tasioulis. I'm currently unemployed, which is just a way to say that I'm taking a bit of a break after a bit of a burnout. I previously worked as a platform engineer, or a platform engineering lead, leading a small team of platform engineers. And before that, as a DevOps Consultant, which is just a fancy title for somebody who goes into client sites and helps software teams modernize their stack and do it correctly. I have lots of experience with AWS and kind of like DevOps tooling, like the HashiCorp stack, but also programming with Python, Node.js, Golang, and that kind of stuff. So really, I'm a bit of an all-rounder. I love learning new things, and that's what drew me into this industry. Other than that, I like traveling, enjoying nature, cooking, eating. I love eating. So yeah, that's me in a nutshell. And this is my Twitter. I don't post much on it, but you can find me there. So this is the agenda for today. And essentially, I will talk to you about observability. And the meat of my talk will be basically some tips that I will give you that will help you achieve observability. So the talk is born out of my previous experience in helping software teams implement observability solutions. And basically getting a better understanding of what's happening in their systems. So I'll talk to you about things that I have seen work in the wild. So there's no doubt that these things do work. Having said that, they may not necessarily fit your requirements. And this is fine. So if you find yourself thinking that, oh, this is not really perfect for my use case, or oh, maybe something slightly different would work better in my system, you're probably right. But nevertheless, the overall concepts apply kind of to everything, I guess. Right, so the agenda is that first I'll tell you what I mean by observability. And I'll do a bit of a literature review to see how the meaning of this technical term has been shaped over the last couple of years. I will discuss how observability changes depending on the platform you're on, like serverless, Kubernetes, infrastructure, or other stuff. After that, I'll talk briefly about what is the point of observability, why do we care, why is it a big deal? And finally, I will give you my tips and then a summary and some predictions for kind of like the future of observability. And I think we'll have some time for questions and answers. So I think it makes sense to start with basically the first hit you get for observability if you Google it. And it's from Wikipedia. And it says, in control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. Right? So in other words, what data does your system produce that tells you exactly what's going on inside it? So I think straight away from this description, it's clear that it's some sort of relation to monitoring, right? And especially when the term observability started becoming very popular in our field about maybe 2 or 3 years ago, a lot of people argued that it was just basically a rebranding of monitoring and nothing more. And while it is true that basically the term can be abused this way, so somebody may try to sell you monitoring but package it as observability to charge you more, in reality the two are quite different. So I have a screenshot here. This is from a blog post by the Twitter engineering team, and this is from 3 years ago, almost exactly. And basically in this blog post they start by describing their observability team as a team that works with monitoring, alerting and visualization, traces, and logs. And in fact, quite usually, we focus on 3 of those, the traces, the metrics, and the logs, as part of kind of like the signals of observability. And these have been known as the 3 pillars of observability, which is kind of like a debated term, but good to know anyways. So to start with, I wanted to emphasize that just doing these 3 things, logs, traces, and metrics, does not mean that your system is observable, right? If you just throw some logs onto an Elk stack, and you throw some metrics onto a Prometheus, and you throw some traces onto a Jaeger, that doesn't mean you have achieved observability. There are more, so you have to do things in a certain way, and sometimes you may have to do more things, or sometimes, in fact, you may not need all those 3, particularly more so in the future, I think, and I'll talk about this a little bit later. This is a tweet that says, the goal of an observability team is not to collect logs, metrics, or traces. It is to build a culture of engineering based on facts and feedback, and then spread that culture within the broader organization. So basically, the problem with observability is not just technical. Because the journey to observability has to include instrumentation of services and has to basically include developer involvement, it's a largely cultural shift as well. And it's part of a mind shift change about what the development workflow looks like, okay? All right. So before I go any further, I wanted to talk about observability in a non-distributed system. So something very simple, like maybe, for example, a simple LAMP stack. So basically, in reality, within that context of a very simple system, observability doesn't have much meaning because essentially, if the system is so simple, you don't really need advanced ways to understand it, right? So yeah, observability in a non-distributed system, kind of like pointless. And in fact, the explosion in popularity of the term observability and the concepts around it is directly related to the fact that basically everybody's now doing Kubernetes, microservices, distributed systems, and basically complicated things. So without a distributed system, you don't really need a new paradigm to understand your stack. Right, so let's quickly talk about how observability changes depending on the platform. And this is basically mainly to ensure that it's clear that my tips are not a silver bullet that will work for everything. But like I said, nevertheless, the concepts do apply to most things, really. So looking at this list, I'll start with serverless. I don't necessarily mean the framework, but kind of like any system where you have lambdas or cloud functions or whatever that work together to produce some kind of work. So obviously this introduces a complexity because you need to be able to understand how each function affects your system, right? So you need to know what it does in your system and how it affects every other part of your system. With something like Kubernetes, the question of observability, again, is a little bit different because with Kubernetes, you may be interested in the underlying infrastructure and basically knowing what's happening in the underlying infrastructure of where Kubernetes is sitting on. But you're also interested in understanding the applications that are running on Kubernetes, right? So this is a bit different again. Equally, for infrastructure, whether it's on-prem or cloud, this is again a bit different because basically understanding what, let's say, something like a load balancer is doing is very different to understanding what a web application is doing. And again, for a web application, whether it's legacy or modern, introduces differences again, because basically for a legacy application, you may not necessarily even be able or be interested in applying kind of like advanced observability practices. Whereas for modern applications, you will want to do that, and you will want to make it part of your software development lifecycle. All right. So before I get to the tips, let's review what is the point of observability, right? So because obviously we should only bother about this if it's actually going to give us something back, right? If it's going to be useful for us. So yeah, the first one is, I say for systems that are under development or change, you need to know what exactly our changes are doing to our system. For systems that have issues, we want to know where exactly is the problem. For systems in any state, we want to be able to ask arbitrary questions and get useful answers about what's going on. And we want to know what the current and the normal and the expected behaviors of our system are. And we want to know what the unexpected or the problematic behaviors are, right? So in particular, an observable system means that basically as you develop and as your code hits production, you want to have that feedback to be able to immediately understand how your code changes have affected production. And I say production in particular because this concept of focusing on production kind of comes with observability. And you may have heard of the phrase testing in production or test in prod or whatever in conversations around observability in particular. So basically, I wanted to take a moment to explain what that is. It doesn't mean that we don't test in dev or in staging or in QA or anything like that. It means that the real truth of our system can only ever be in production, right? If you push, let's say, a code change and then something breaks, it doesn't really help if you say, oh, well, it was working in dev or it was working in QA, right? In reality, production is the real test. And it's kind of like it's kind of like parallel to, in the past you would say, oh, it's working on my laptop though. And that's just not good enough for kind of like a high performance team and software kind of like that you're trying to produce. And this is also what observability driven development is about, right? This is the concept that when you're developing on a system, you want to be able to see clearly what your changes are doing, and you want to be able to see the results and iterate on that knowledge, right? And while this may sound kind of like self-evident, it's a fundamental shift to how we approach kind of like the way we produce software. Because we all know that we need good testing, and we all know that there's best practices for development, and that we need to have alerts and monitoring and this and that. But in reality, I've seen the way that many teams work, and what ends up happening is that you may have like a pull request review that's not necessarily that useful or that in depth, and then the code goes through unit tests that may not necessarily catch everything, and then you go to like end-to-end tests, and these are notoriously difficult when you're talking about large microservices systems or distributed systems. So in the end, what happens is that code gets pushed to production, you see some weird behavior out of it, somebody's on call, they get an alert, they try to figure out what's happening, they have to look at a million places at your metrics, your logs, your traces, your Git repository, your error reporting, and all that, and then you piece a million pieces together, and you figure out what's been going on eventually, and you can't help but think, damn, this really should have been much easier to figure out, right? You don't want, especially for your on-call people, this to be that difficult. So yeah, basically, observability comes with this idea that you need your developers to have kind of like ownership of their code and of the system that it is running on. And in order for this to make sense, you need to have an observable system, right? And to flesh this out a little bit further, observability is not achieved if your system just produces a bunch of data that you can use to then basically understand your system, unless you actually use it, right? Just producing the data is not enough. You need to be able to process it, visualize it, manipulate it, and eventually you need to also actually use it to do something differently, I guess. Right, before I move further, let me just take a quick moment to do a review on this, basically logs, metrics, and traces, just to make sure that everybody's on the same page. And these are kind of like my descriptions, and they're not necessarily 100% accurate, I guess. But for logs, I'm going to say they're detailed, custom, and highly customizable information about what our software is doing, right? This is a key point with logs. You can very easily manipulate what you're logging, right? Metrics, they're pre-aggregated statistics, and the key word is pre-aggregated, describing the general status of our software. I'll get back to why pre-aggregated is so important here. And we have traces, which are kind of like structured logs that let us see how the components of our system interact. And this, you may think twice about that. And added an asterisk about that to say it's actually more nuanced because of looking at a trace versus looking at tracing data. This is something that Ben Siegelman talked about yesterday in his talk. Okay, and then I also have this tweet here from Charity Majors from Honeycomb, which kind of summarizes the different way of thinking around monitoring and then observability. So you see conventions associated with monitoring. You have operations, black boxes, metrics, dashboards, alerting, rapid diagnostic of recurring failure conditions, thresholds using clusters of symptoms plus intuition and mental models to infer root causes, runbooks, etc. Whereas with observability, you have software development, APM, instrumentation. This is a very important one. I'll talk about this in a bit. The health of the event matters more than the system. That's another really important one. And the fundamental idea here is that when, let's say, you're monitoring a system, you may have green metrics or green health on everything. But if you have one customer who maybe doesn't have that many requests, so they don't really show up on your graphs, who's getting failures for all the requests, as far as they're concerned, your system is down, right? So you need to be able to understand your system at the level of every event. High cardinality, tracing, slower or open-ended exploratory investigation. This is in opposition kind of to rapid diagnostic of recurring failure conditions. So the idea here is what I mentioned briefly before, that you need to be able to ask arbitrary questions about what's happening. You want to be able to investigate. You don't want just to have kind of like a number of graphs and then kind of like look through the graphs to see where something looks abnormal. And then iterative debugging, and everything ties back to build IDs and lines of code. Right, so I'll get to the actual tips. This is meant to be general advice. Your mileage may vary. This stuff does indeed work. So my approach starts with superpowering your logs. And I propose logs as the central signal of observability due to their highly customizable nature. And of course, I think the immediate question that may come to mind is that logs are a really old and kind of boring concept, and observability is such a new, hyped up kind of like deal. So how do you actually go from boring old logs to that basically everybody knows and they're not always that useful, to achieving observability for a microservice architecture? This is what I'll talk about. And essentially, in my experience with sufficient care, your logs can be so powerful that you may not need separate metrics or tracing platforms. And that's because logs can be used to extract metrics out of ad hoc and can contain tracing information. So in fact, you're not losing anything. You're just consolidating and avoiding data duplication. Right, so tip number 1 is stream your aggregated logs. And I've kind of combined 2 tips in one here. The first one is that you need to aggregate your logs, but this is kind of like so basic that I'm not going to put that much emphasis on it, because obviously if you have microservices and you're not aggregating your logs, you have no hope, basically. And then my advice is to stream these logs as opposed to storing them on disk. And that's because essentially storing logs on disk should be avoided in favor of a streaming architecture, because storing on disk is basically less flexible and more error prone. So ideally, you will have a streaming architecture that you can scale both in terms of how many logs you can push through it, but also what types of logs, and the producers and the consumers and the types of data routing that you can achieve. And specifically, the problem with storing logs is that it's not as fast as streaming, first of all. And also the amount of times that I've seen basically a machine die because the log filled up, because the log rotation failed somehow, is just uncountable. I've seen that a million times. So the streaming destination can be really anything. It can be an online service, like one of those. Or it could be an on-prem solution, like basically like an Elk stack. This is the most popular one, I think. I'm personally not a big fan of the on-prem Elk solution, because basically it's, especially for a startup or a young team, it can take a lot of time from your developers and a lot of resources. And I think investing in a good online solution will save you a lot of trouble. Tip number 2 is stream through a pipeline. So this is obviously related to the previous point, but it goes a bit further in the sense that You may want, for example, application logs and database logs to be handled differently. But it's nice to still have a single logging pipeline that you can use to do kind of like different requirements and different things. And I have this graphic here from you. This is taken from a very interesting blog post. I've put the link down there. And basically what this shows is kind of like the concept of this observability pipeline, where on the left you have kind of like the producers, which are the containers in this case, and then the collectors, which send to a data pipeline, and then through that you get to a data router and then a backend, right? And you can see that this is really kind of like agnostic. You can use tons of different technologies. So you don't have to use some specific for that. Tip number 3, create standards and libraries. So you should create standards that specify what your logs should look like, okay? In terms of the format, in terms of the content, etc. And these standards should then be expressed through software libraries, right? So the idea here is that these libraries are going to be like wrappers around your main methods for Golang or Node.js or something like that, or maybe it's a decorator in Python. And it really, I guess it depends on the programming language in question. Or they can be a separate function. But the general idea is that you have a central library, and this library implements your standards, and it makes it easier for your developers to actually take care of the grunt work of basically the logging setup. Tip number 4 is structure your logs. Again, this is related to the previous point of creating standards. And the standards are basically to prescribe a structure, because if your logs are not structured, they're not worth anything, really. What this structure will look like depends on your requirements. I will show a couple of examples in a bit. If you're not sure where to start by doing it all in JSON, valid JSON. It's a good start. And this will basically help you in later on processing and parsing your logs and visualizing it in whatever your visualization layer is. And the other thing in terms of structure is that you should decide ahead of time what fields you want to have included in kind of like all your logs. So for example, maybe in a microservice environment, you will want every single log to tell you what service it came from, right? You want to know what service it came from. Or you want to know the timestamp or the duration that this bit of work took, etc. Tip number 5, add lots and lots of context. So it's important to add tons of context. And this is context about what the system was doing when that log was emitted, right? For example, this can be information about the user that made the request. So this could be maybe something like the operating system they're on, or the user agent, or something like that, or anything like that. You want to have information about the system itself. So maybe like, I don't know, the CPU load or like the memory situation in your system at the time of that log. And you can also have information about the state of your user on your system. So for example, let's say if you're an online store, you may want to have information about, let's say, what product they were looking at or what they had in their cart or whatever. And really the main point here, the main takeaway is that you should add as much context as possible here, okay? You should not be afraid to add a lot of context. The more the better. And this is because you need this raw data to get a full picture of what is going on. And in fact, this is also why metrics, you remember previously I said metrics, they're pre-aggregated statistics. This is why you can never get the full picture for metrics, because you've already aggregated them. That's a one-way street, right? You want to have all the data, all the raw data, and then process it and figure out what's happening. And that also opens you up to the idea that you can ask arbitrary questions, right? You have all the data there, you can ask arbitrary questions. Tip number 6, sample your logs. So if anybody doesn't know what that is, basically the idea of sampling is that, let's say you have 100 requests and 99 of them were a 200 for the same thing. You don't necessarily need to see 99 same log lines, basically. You can sample that and keep only as many as you think is useful. So basically, that allows you to avoid having huge amounts of data, right? So this makes it easier to cope in terms of, to work with in terms of amount of data that you're working with, but also in terms of the expense that this will incur. So basically we're counteracting the fact that we're saying you should put as much context in it as you want, or as you think you may need, and basically don't be scared to do that. So your logs will be huge, but then sample your logs to not have unnecessary data. Tip number 7, add tracing information. So I mentioned before that logs can carry tracing information, and that traces are a form of log. And in the simplest form, what this boils down to is just adding something like a trace ID, or request ID, or correlation ID, or transaction ID, or whatever you want to call it. Basically some sort of ID that uniquely identifies this request, right? And ultimately what this allows you to do is that if, let's say, you have a microservices environment and you have 10 microservices, as a request flows through your system, it will hit at least some of those microservices, and you will be able to put the picture together by basically using this ID, which will be common for all these log lines, right? So then, for example, if the request fails, you can immediately see where exactly it failed from your logs and why it failed, hopefully. Then I have kind of like an optional tip number 8. This is log events, okay? And a simple way to think about what is meant by event is that one trip through a service, through a microservice, should result in one log line, right? So what's the point here? The point here is that many times you have a microservice and it does a few things, and maybe as the request goes through that microservice, you have, let's say, 5 points where you log something out. When you're adding so much context to every log line, as I said before, you actually know already that the context for every single one of these 5 logs is going to be the same anyways. So instead what you should do is keep basically the messages that you intended to emit, and then put them in a single log. And then at the exit point of the microservice, you emit one single log instead of logging 10 things throughout the microservice. So depending on the nature of the microservice, this may be difficult to pull off correctly, and that's why I kind of put it as optional. All right, tip number 9, this is more of a clarification. Instrument your services. So basically, you will need to instrument your services for observability. It comes at the cost of this, basically, of this manual implication of your kind of like developers. They have to do this. And in fact, as your services change, your developers are going to also have to adjust what they're doing for observability. And also, if anybody, in particular a vendor, tries to tell you that their system will offer you observability without the need for instrumentation, they're lying to you. And actually, in fact, there's 2 points here related to the fact that I said this is also about how you develop software, right? You not only need to instrument it, you not only need to adjust the instrumentation, but then your developers need to be involved in actually using the results of this instrumentation. And that's what the tip 10, which is kind of a conclusion, boils down to, which says actually use your data, right? And using the previous tips, you get very nice data, which is structured, which is useful, which has all the information you need. And now from that, you can get visualizations, you can get correlations, you can get metrics, and all you need is a good tool to process your data. Right, I have now, this is it with the tips. I have now a few screenshots that kind of show what this would look like in practice, potentially. So this first one is part of a CloudFormation definition, and this is a kind of like AWS native JSON-based configuration management language, I guess. And basically what this shows is that we're adding tags to every log, And the tags include information about the image. This is context, right? About the Docker image, the environment, like dev, production, whatever, the name of the service, the container ID, the region, this is the AWS region in this case, and the stack, right? So immediately, basically, just by doing this, every single log that gets produced on your system, on that system, has this context every time. So basically, this is it's a great solution because it's just so easy to do it, right? All right, this is an example of a log. This is taken from a real kind of like case, and this is from a machine learning service. You can see that it's a very rich log, right? And it's got quite a lot of data. But basically, you can see that there's like tons of nice information here. You got starting from up there, you got the environment, it's the dev environment. You got things about the machine learning model. It tells you the model version. It tells you things about the model names that were used in this case. And then you also get context about the user, like the user ID, the client IP, etc. You get information about the state of the system, the number of CPUs, the memory in use, etc. And you get a bunch of other information down here. So yeah, basically you get a very full picture of what was happening in your system at the time. And this is a good example, I think, of structured logging. It's not a perfect example, but it's a realistic depiction of what this is going to look like, of what the concepts I talked about look like in reality. This instead is an example of basically something that's trash. So what you see here is a timestamp, and then you have kind of like a long message line, which has, again, tons of information, but it's all unstructured, and this is difficult to work with, right? And you're not going to be able to do much with this. So this is something you don't want to see on your system. All right, and this is basically the same as the previous line, but just expanded to be structured, right? So this is what it boils down to. You structure it like this, and then basically you can do things like, you see, for example, up there, it says duration in a mess. If you want to find only the logs that had a higher duration than whatever, you can just parse that through your kind of like logging system very easily. As a kind of a side note, I've personally had a lot of success implementing these concepts with FluentD, which and Humio. And FluentD is a great tool, which is in line with the idea of the logging pipeline, or the observability pipeline that I talked about before. And it makes it fairly easy to work with the types of rich and structured logs that I've talked about. And Humio, on the other side, is a great platform to process and visualize the data at the end of this pipeline, I guess. Having said that, like I said before, this is not, this is just an example, and you can do this stuff that I'm talking about with any tool, really. But I just want to give you an example of what this may look like if you're thinking, okay, that's all fine and good, but how to actually do this? Go check out their websites, and you'll get some inspiration to get started. This here is a screenshot from basically processing structured logs. And you can see the query line at the very top, which basically gets requests and then sorts them grouped by their trace ID and sorts them by their duration. And you can immediately see which basically requests through your system had basically long duration, were slow. And this is just a simple way to use that structured data and get immediate kind of like feedback about what your system is doing and what each event looks like on your system. So this is a bit of a summary, aka Alex's 3 pillars of observability. So I say you should have rich context, that you should have tracing information on your logs, and you should have structured events. Now, for the future of observability, as is evident, I think, from this talk, it takes time and effort and careful thought before you can achieve a sufficient observability for a sufficiently complex distributed system. But I think we're approaching a point at which instrumenting observability signals should not be such a big pain and should not be an exercise in reinventing the wheel, because basically these things that I've talked about today, I've seen many teams do them, and they all go through a lot of pain to basically achieve good results. I have a quote here from a very interesting but also very heavy blog post, and it's really, I hope you can read this. It says, the right path could accept raw events, demukes them into metrics, traces, and logs heuristically or by the shape of the data, make the relevant optimizations, and store them into purpose-driven backends. The read path could provide a single pane of glass style interface abstracting over those backends. And I know this is a complicated sentence to understand, really. So basically what this boils down to is that at the end of the day, logs, traces, and metrics are all kind of like different sides of the same coin. They're all just expressions of what's happening on your system. And they're what we have come up with to this day for basically helping us understand our system. But in the future, there should be kind of like a single signal that captures all of that information, right? And this is kind of the direction in which I've tried to steer this by saying that you can include tracing information in your logs, and then you can use the logs to create metrics ad hoc, right? And I see no reason why vendors or open source tools in the future basically will allow you to get what we currently get from traces, metrics, and logs all together, but from a single signal instead. Right, and finally, I have a summary of all the tips. There's 10 tips. Just to go through them again: stream your aggregated logs, stream through a pipeline, create standards and libraries, structure your logs, add lots and lots of context, sample your logs, add tracing information, log events, instrument your services, and use your data. And this concludes my talk. Thank you very much for your attention. Enjoy your evening, enjoy the pub.